So yes, I'm Jason Mays. I am the developer advocate for TensorFlow.js here at Google, although currently live from my bedroom due to the working from home situation going on. Yeah, thank you for inviting me to the talk as well. I'm happy to be talking to everyone over there in Germany and beyond. I think there's some people from other places too. And today I want to talk to you a little bit about machine learning in JavaScript and why that actually should be a consideration. And a little bit about me before I get started here. This slide kind of summarizes my kind of career journey to date. I started off as a computer scientist many, many years ago at the University of Bristol over in England. I'm originally from the UK. And I joined many startups after that, working as a web engineer for many years. And then after doing this, I founded my own company, which did web consultancy and this kind of stuff. I went into full stack web engineering that allowed me to then be able to make anything I wanted from beginning to end, including front end, back end, design, UX, all this kind of stuff, which allowed me to then create prototypes for people. And that led me into a role as a creative engineer or creative technologist at Google, where we'd be creating prototypes for Google's top 100 customers globally. So trying to make never been done before things to tell their story in an innovative way. This led me to prototype engineering, and you can see some of the projects I've been involved in there, just a few little bits and pieces that I'm allowed to talk about publicly. And then, of course, in the more recent past, I transitioned into developer advocate for TensorFlow.js, essentially combining my love for JavaScript and machine learning into one role. But there's one thing you take away from this slide is that I spent 16 years of my life working with JavaScript. Which is pretty much half of my life or more. So basically, I like JavaScript a lot, and I'm happy to share with you why that is today with some interesting use cases. So as mentioned, if you have any questions at any point, feel free to just unmute and chat with me. I want this to be a discussion with everybody. I'm totally happy to talk about anything in more detail. But with that, let's get started. And machine learning in JavaScript, why do we want to consider that? Well, first off, you can use machine learning anywhere JavaScript can run. And right now, that's a lot of places, actually. In fact, JavaScript can run in the web browser, server-side, on desktop native applications, mobile native applications, and even Internet of Things. And if we dive into each one of these areas in more detail, you can see many of the technologies you may have heard of before. So many of the popular web browsers there on the left-hand side. We have Node.js for server-side environments, React Native, WeChat, progressive web apps for mobile applications, Electron for desktop, and of course, things like the Raspberry Pi for Internet of Things. And of course, we can run on the Raspberry Pi because it's just a Linux-based environment that you can install Node.js on, essentially. So it's very flexible, and the only language that can run across all these places without any extra add-ons or plugins and this kind of stuff is JavaScript. So for that reason alone, JavaScript is very useful because you can reuse your code over many different locations. And that can save you a lot of hiring situations, trying to have programmers with different expertise. You can just hire one person to bring it across the whole stack. So TensorFlow.js is an open source machine learning library, and essentially allows you to run, retrain via transfer learning, or write your own machine learning models completely from scratch from a blank canvas. And if any of you are already using machine learning, maybe you're using our Python implementation of TensorFlow, you can do exactly the same stuff that you can do in Python, but in JavaScript as well. And that means you can basically use it for anything you might want to dream up, from augmented reality, sound recognition, gesture recognition, sentiment analysis, conversational AI, all this stuff and much, much more. All the things you know and love can be done in JavaScript as well now. So there's basically three ways you can use TensorFlow.js, and I'm going to go through these three approaches in this discussion today. And which approach you might take will depend on your experience level, your confidence with machine learning in general, and of course your confidence in JavaScript. So depending what level you are in each of these areas, you might want to choose a different approach to start with. Now, the first approach is to talk about our pre-made models. These are simply really easy to use JavaScript classes for many common use cases, and you can see some of them on this slide here. So we have the ability to do things like object detection, body segmentation, so finding out where pixels in an image belong to a human body, pose estimation, what is the skeletal position of that body in the image. We can do speech command detection, and even more advanced models like our face mesh to detect points on the face, hand pose to do similar things for your hands for like gestures and stuff like that. And our newer BERT Q&A model, which is for natural language processing, allows you to do natural language processing in the browser to do some really cool advanced things. So as an example, it can allow you to, let's imagine you're on a really long web page, a really long article, and maybe you're not an expert in what the article is talking about, and you want to find an answer to your question. So maybe you're on a Wikipedia page about crabs, and you want to know, how do crabs walk? And maybe there's nowhere in the text that explicitly says that phrase, but using natural language processing, we can actually find the piece of text that is relevant to how a crab moves. And that then can be highlighted and shown on that page. So there's many potential examples you could use natural language processing for. So I want to dive into some of these high-level models just to give you a feel of how they work and what is possible with them. Now, the first one is object recognition. This is actually using a machine learning model known as COCO-SSD behind the scenes, just a very fancy name for a cool model. Essentially, this has been pre-trained on 90 object classes. And what that means is that out of the box, without you having to do anything, it will recognize 90 popular objects, like these dogs you see on the page right now. So things like dogs, cats, humans, mobile phones, things like this, common objects you probably expect to see in everyday life. There's a good chance it knows what those objects are. So let me just go ahead and show you a demo for this. And note how we're getting the bounding box information back here as well. So not only are we knowing that the dog is in the image, we know where in the image it is. And this is different to image recognition, which will tell you that it's seen something, but it won't tell you where it is. So object recognition is a little bit more advanced than image recognition, just FYI. That's the difference between the two. So let me go ahead and share a different tab here. Now, this is a live demo I've written that runs in the web browser. I can actually send around the link afterwards. This is public on our examples repository. And you can see here, I can actually click on any of these images, and in real time, I can get classifications back of the objects it's found using our COCO-SSD model. And you can see here, this naughty dog is trying to get the treats, and we can see there's a bowl, there's a cup, and the dog all in the frame. So we can then infer that this dog is maybe being naughty, and you can very easily, using something like this, you could make your own smart webcam or something like this that could detect when your dog is being naughty around the house or something like this. Or on the right-hand side here, we can actually segment the people from the dog. And even though there's multiple objects in the scene, we can still get their individual locations and then do something useful with that information. So maybe in our current times, you can have a social distancing kind of application here to warn if someone's coming too close or something like this. I don't know, whatever it might be. And of course, this is great in imagery, but I can also enable my webcam because JavaScript is a very rich tool for doing multimedia and visualizations. In fact, the web was designed for the presentation of information. So compared to other languages, JavaScript has a very rich API and libraries to do very advanced things. And notice how it's classifying me right now in real time in my bedroom, and it's showing me as a person with 92% confidence. So it's 92% sure I'm a real human being. And that's great. And this code to do this, you can just take the code I've got online right now. You can fork this yourself. And in minutes, you can have this working, and you can start playing with this to do things that might be of interest to you. And notice how fast it is running. I can move my hands, and the bounding box gets bigger and smaller. There's no performance issues. JavaScript is no longer a toy language. It's very advanced. It's very optimized. And in some cases, can be faster than other languages. So let's go back to the slides to see more. Any questions on that before I move on to the next example, by the way? Feel free to shout if any questions. If not, I'll assume the stunned silence is a good thing, and I'll go on to the next one. OK, perfect. So next up, we have face mesh. This model allows you to identify 468 facial landmarks, as you can see with the animation on the left-hand side of this screen. And it's just 3 megabytes in size. So it's a super small model and super powerful. In fact, Modiface, who's part of the L'Oreal group, you may have heard of L'Oreal, have actually used our face mesh model to do augmented reality makeup try-on, as you can see from the image on the right. In the image on the right, the lady is not wearing any makeup. The lipstick is rendered in real time in JavaScript, and you can select from the shades at the bottom there to try on different shades of lipstick without actually having to touch the product or go to the store in real life. And you can see that the rendering is very realistic, and it gives a good representation of what it would look like if you were to buy that particular shade of makeup. So once again, I'm just going to show you the face mesh model in action. And if I share my screen here, you can see, once again, I'm live in the web browser. And you can see as I'm moving my head around, it's very robust. It's tracking me very well. And you get a very high granularity. And because this is JavaScript, once again, not only are you getting the machine learning classification on the left-hand side here, in real time, I'm actually rendering a 3D point cloud of my face on the right using WebGL and 3.js. So you can see I can open and close my mouth there, and on the right-hand side, I can, in real time, inspect my face from all different angles, as you can see on the right-hand side here. Now, one thing to note is that this demo right now, I'm running using WebAssembly. You can see this drop-down has WASM selected. All that means is that it's running on the CPU and not the graphics card of the computer. If I were to change this to WebGL, we would then shift the model to run on the graphics card. And the cool thing about TensorFlow.js is that we can actually leverage any graphics card that supports WebGL, which is a lot of graphics cards. You're not just limited to the NVIDIA ones that typically, if you're using Python, you can only use NVIDIA because the low-level libraries only have support for the NVIDIA drivers. With TensorFlow.js in the browser, we can use any graphics cards. So even if you're on a MacBook, which typically is very hard to do machine learning on, we can even run on those too. And of course, if I changed to running on the graphics card and your machine had a graphics card, then I would get much higher frames per second than the 20 frames per second I'm getting just on the CPU right now. In fact, I can get up to like 45 or 50 frames per second if I switch to my graphics card. But as I'm live streaming right now and sharing my screen, it's a little tricky to show you that because I'm using all my graphics card power to share my screen right now. But basically, I can get 45 to 50 frames per second if I were to switch that, which is kind of nice. And once again, very real time and lots of interesting applications in terms of augmented reality or whatever you might dream up. So back to the presentation. One moment to share this tab. Cool. Any questions on face mesh before I go forwards? Oh, OK, cool. Next up, body segmentation. This allows you to distinguish 24 body areas across multiple bodies all in real time. This is kind of hard to demonstrate from my bedroom, so I'm just going to show you this animation for now. But essentially, you can see here that as people are moving around the scene, we can actually find their bodies in the frame, and we can also find their estimated pose, as you can see by the lines that are drawn within the bodies. So with this, you can potentially recognize a specific pose or a gesture or something like this. So a very powerful model. And the kind of interesting thing here is that with a little bit of imagination, you can use this model or any of the models I've shown you in very creative ways. Here's just two examples I've created in my spare time. On the left-hand side, you can see how I remove myself from the webcam image in real time to turn me into a ghost, essentially. And notice how when I get onto my bed, you can see the bed still deforming in this middle image. So watch as I move across the bed still deforms, but I'm removed in real time from the frame. So you get this kind of Harry Potter-like effect where like invisibility clip kind of style. And I made this in just one day, okay? This didn't take me much time at all. And all I'm using here is the body pics model that you saw on the previous frame. If I know where my body is, I also know where my body is not. And with that, I can build up a knowledge of the background, and then I can only show the background over time. On the right-hand side here, you can see an example of me trying to estimate my size for clothing. And I don't know about you, but I'm terrible at buying clothes online. I always never remember what size I am, and every brand has a different kind of way to measure if you're a small, medium, or large, and all this kind of stuff. So now in under 15 seconds, I can measure my body to centimeter level accuracy, and I can then automatically select on the website what size I should pick for my shopping cart. And that's great because that means less returns for the business, and it's a happier customer because I can feel more confident that I'm ordering the right thing in case my size or shape may have changed as well. So I can then have a higher guarantee that I'm going to get the right thing in the post later on. And once again, I created this in just 2 days over the weekend because I was frustrated, but I couldn't figure out what size I was. So this again is using the body pics model that you saw on the previous slide. And it turns out if I know my height, I can then, if I recalculate frame by frame with body segmentation and I know my height, I can figure out how many pixels per centimeter exist, and then I can measure things in the room and all this kind of stuff. So with one simple measurement, I can then calculate all the other measurements I need to know my clothing size. And of course, most people know their height to a reasonable accuracy. So that's kind of an easy one to do. And of course, we can go further. We can give you superpowers. This guy from our community, he is from the USA, and he has combined with WebGL shaders to kind of shoot these lasers from his eyes and mouth. This is just a fun, creative example, but you can see how fluid and how real-time this works. So you can do some really advanced 3D graphics in JavaScript too, and this may or may not be of use to you in your businesses, but like it just shows like how powerful you can be with JavaScript and have these very interesting effects. So if you're in the movie industry or something like this, you can have these realistic renderings coming back as well if you so desire. And you can go further. You can combine with many other web technologies. This guy from Paris in France, once again from our community, figured, well, if I can figure out what the body is, I can look at a magazine and I can extract the body and then put the body in my room. And now he can scan any magazine and then inspect that fashion in life-size form in his magazine to see if he likes that or not. And he's combined this with like some cool WebGL effects. So he's got these particular effects that you can see just to make it more visually interesting. And notice this is running on his mobile device. This is not on a desktop or a laptop. He's running this on a 2-year-old Android phone that he had lying around. And so it can run very nicely even in these kinds of situations. And of course, I saw this and I was like, okay, well, hold on a minute. Well, let's go one step further. Let's combine it with real-time communication. In the current times, we're stuck at home. It's very hard to meet people. I thought, wouldn't it be nice to be able to actually have a conversation with people, much like we are having right now, but in a more meaningful way? So I figured out a way to transport myself in real time anywhere in the world, and I can place myself in your living space. So I appear to be standing right in front of you. And in much of the way we're having a conversation right now, instead of being limited to a rectangle on your screen, you can walk up to me, you can walk around me, and you can actually have a more meaningful interaction. And it really does feel like you're there with the person. It's hard to describe without trying it, but by placing you in that space and hearing the sound coming from the right, placing your headphones, you can have positional sound and all this stuff too. It really feels much more realistic and much more personal. And this is a great way to connect with people in the current times when it might be hard to do so in person. And yeah, just to talk about that, the web is, JavaScript has so many interesting APIs now that go beyond just the presentation of information on web pages. It supports things like mixed reality, augmented reality, all this 3D stuff. So it's really easy to do this kind of stuff these days too. And then transfer learning. This is the second way you can use TensorFlow.js. So once you've used our pre-made models, so all the stuff I've shown you made use of pre-made models. These are like simple, easy to use models. With transfer learning, essentially the idea here is that you can now use the models that you've seen on your own data. So maybe you're gonna retrain them on data that matters to you. So maybe the object detection model can recognize cats, dogs, and humans, but maybe you want to recognize, I don't know, like bottles of water like this, and that might be very specific, and you want to know the difference between this bottle of water and a different brand of bottle of water, right? So for that, you need to give it custom training data. So I want to go into a couple of methods you can do to do that in a really easy way. And of course, if you are a machine learning expert, you can of course do this in pure code if you want. We've got tutorials on how to do that, but I want to show you 2 easier ways to do this. Now, first up, we've got a system called Teachable Machine, which is a web browser-based experience. Everything is trained in the web browser, and everything happens in the web browser. So your privacy is completely preserved, and it's a very fun way to make a prototype in minutes. In fact, everyone on the call today, after the show, can go to this website, and you will be able to recognize something in your room in exactly 2 minutes, like I'm about to show you right now. So let's dive into the demo and see this in action. So if you go to teachablemachine.withgoogle.com, you'll be presented with this landing page like so. And you can actually do 3 things out of the box. You can learn to recognize certain objects, you can learn to recognize some audio, or you can learn to recognize some specific pose. And of course, this will probably grow with time, but right now, this is all the team has managed to output to the world right now. But let's click on images. Now, if we click on images, we can see we've got class 1 and class 2. And you can add more classes if you like. So if you've got more than 2 things you want to recognize, you can add another class by clicking on the Add Class button at the bottom. But for this demonstration today, I'm just going to go with 2 things. Now, the first thing I'm going to recognize is me. So I'm going to put Jason here. And all we have to do is click on webcam. You can now see it's got a live preview of me as normal. And I'm just going to sit here and click hold to record to get 30 or 40 samples of my face. as so. So we're going to move my head around, and there we go. We've got 39 images of Jason in there. We're now going to go to class 2, and here I'm going to go cards. I've got a deck of playing cards in my room, as you can see here. And we then click on webcam for class 2, and we're going to do exactly the same thing. And we're simply going to get 30 to 40 images of the deck of cards. So hold to record, move it around for variety. Oh, 30, there we go. We've got 44 images of that blue deck of cards. Now we're going to click on train model. And what's going to happen is in the web browser, live as I'm speaking, it's going to retrain the top layers of this model so it can take its previous learnings and try and apply that to this new set of data that I presented it with, so it can try and learn how to separate it from each other. And there you go. In under 30 seconds, we can now see a live preview come back with the model trained. You can see right now it says Jason with 100% confidence, so it's very sure I am of the Jason class. And if I move the deck of cards into view, you can see it now says cards. So Jason, cards, Jason, cards. And in just 2 minutes, we've managed to make a machine learning model that can distinguish myself from a deck of cards. Now, that's not very useful, but of course, you can imagine if you're trying to do anything else, like maybe you want to see if your garage door is open or closed, and you can automatically close it via a Raspberry Pi if you've left it open. You can do whatever you like with this kind of technology, and in minutes, you can make something for a prototype. Now, I want to emphasize that this is good for prototyping, because if you have gigabytes of data, which typically, if you want to train a more robust machine learning model, if I showed it like, I know, a different set of cards with like different colors, maybe it'll get confused. So you need more variety of training material to have better robustness and less bias to make a production level system. And I'll show you how to do that in just a second. So this is great for prototyping to prove a point out. And in the case of startups, this is great because you can just prove to investors that, like, you know, something actually will work, and you just need to have the investment to make it more robust later on. So this is great for prototyping. So let's just go back to the slides 1 second. Any questions on Teachable Machine before I go to the next topic, by the way? No? OK, cool. Let me go to the slides. I am presenting the slides. Great. Good stuff. So I spoke about Teachable Machine, which is great for prototyping. But next, let's talk about Cloud AutoML. This is basically kind of like Teachable Machine, but based in the cloud, and is suitable for production use cases. So here you can see someone who's trying to classify flowers, essentially. And all they've done is they've uploaded gigabytes of flowers in different folders, and they've uploaded it to the Google Cloud system. And they can simply click Next, and they can then specify that we want Google to train for us a model that has higher accuracy, a trade-off, or faster predictions. And you've got this kind of like basic kind of slider here. And of course, you have to choose one way or another to either have file size or higher accuracy, essentially. And you can choose what's better for you, and you click Continue. And after a few hours, what's going to happen here is Google is going to, on your behalf, try hundreds of different models, which we believe to be cutting edge for this task, which is computer vision in this case. And we're going to try thousands of different hyperparameters so you don't have to. And we're going to do all that hard work for you. And after a few hours of training, you can set your budget for how long you want to explore this space for. And whatever budget you set, you can then have more or less time to kind of search this space for the optimal solution. And after those few hours, you'll then be able to download the model that it's produced. And one of those options here is, of course, to download in the TensorFlow.js format. You just click on Export, and you download a zip file that contains a couple of objects. It's got a JSON file, which has some descriptive stuff about the model itself, and it's got some binary files which contain all the model weights and parameters that have been trained. So you can then host that on any website you wish and use it then on any website you like to then classify the things you had trained on. So how do you do that? It's actually really simple. And even if you're not a JavaScript developer, I'm just going to walk through this code. It should roughly make sense, even if you're not a JavaScript person. So essentially at the top here, we've got some HTML, which is just importing the libraries that we need. So the first line here is just importing the TensorFlow.js library. The second line is just importing the Cloud AutoML library. So nothing fancy, just like a regular import. The third line here is also some HTML for a new image that you want to classify. So here is a random daisy image I've got from the internet. This is just an image tag in HTML with a JPEG that we want to classify. This could be a webcam image. This could be something else. But for simplicity, I'm just showing it here as a plain old image. And then the actual JavaScript we need to write is actually contained within the 3 lines of code. Super simple. So we've got a function, and all we do is we need to load the model that we just produced from Cloud AutoML. So there's this nice function called tf.automl.load image classification. And you can see this just referenced the .json file that you would have downloaded from the previous step. So that would be hosted somewhere on your web server, and you just point to that path in this model.json link here. And then we use the await keyword because sometimes machine learning models might be a couple of megabytes in size. So it's an asynchronous operation. It means it will take some time to download. So we use the await keyword in JavaScript to say, wait for this to happen, and then assign it to this variable on the left. Now, once we've got our model loaded, we can now get a reference to the image we want to classify. So this is the new image we want to classify, our Daisy image above. So all I'm doing here in JavaScript is I'm just getting a reference to the element in HTML called Daisy, which is this image on the 3rd line. And then all we need to do is call model.classify with the image we want to classify. And once again, machine learning operations are run sometimes on the graphics card, which can be an asynchronous operation. So we have to use that await keyword once again. And what will happen is the JSON object that comes back from that will be assigned to our predictions variable. And that's just a JSON object that you can pass through with all the things it's predicted from the image. So in just 3 lines of JavaScript, you can basically get the results back and then do something useful. So very simple and very easy to use. And this would be production level machine learning model that has been trained on gigabytes of data and tuned to a very nice accuracy. So that's transfer learning. And of course, the 3rd way to use TensorFlow.js, if any of you are machine learning experts, maybe you're using Python already, you can write your own code just like you do in Python. And I'm not going to go into how you do all that because that requires you to just learn how to do lots of programming and stuff. There's many books on this. But I'm going to focus on the superpowers and performance benefits of doing this in JavaScript or Node.js specifically. So a quick overview of the TensorFlow.js stack. Essentially, we've got 2 APIs available. We've got a high-level API, which is our layers API. And if any of you are using Python, this is almost exactly the same as Keras. So very high-level, easy-to-use functions to build your machine learning models from scratch. Now, if you are more mathematical and more low-level, we have a low-level API called our Ops API that allows you to actually tweak things like how we do all the linear algebra and all this stuff behind the scenes. So if you do want to get really down and dirty with the mathematics, then you can actually go to that level as well, and all of that is exposed, just like they do in the original TensorFlow implementation. So very similar APIs to what you're already used to. And you can see how this comes together in this nice chart here. So we have our pre-made models that we spoke about earlier in the discussion. They are built upon the layers API, which we just spoke about, that nice high-level API. This layers API sits on top of this Ops API, which is the low-level version. And this lower-level API can basically run in different environments. So you can see here, we can run on the client side, which is basically vanilla JavaScript, so things like the web browser, WeChat, React Native. And each one of those environments can talk to different backends. And by backend, I mean like more of the hardware that it's running on. So we can run on the CPU, and CPU is always there for us. We always know how to run on the CPU. However, that's the slowest method of execution. If there's a graphics card available, we can choose to run in WebGL, and that will give us the graphics card acceleration on the front end. And if we have WASM available, WASM is WebAssembly, that can give us higher performance on the CPU, as we can make use of the lower level instruction sets of the various processors out there. So you can actually then run much faster on older devices or even newer devices, but you get more consistency on the CPU. And in some cases, it can be as fast as running on WebGL for certain types of models and such. So very, very powerful stuff. Now, looking on the server side, you can see we can also support server-side environments via Node.js. And that also includes things like Raspberry Pis and things like this. So anything that can run Node.js, I'm talking about as a server-side environment here. And essentially, this has 2 different backends, the TensorFlow CPU and TensorFlow GPU. And once again, this is exactly the same backend as Python uses. So if you're unaware, Python TensorFlow, which is very popular right now, actually talks to the C++ implementation. TensorFlow is actually written in C++. So Python has bindings to that C++ to make use of the graphics card and the processor. And Node.js talks to exactly the same binding. So you get the same performance or better, as we'll see later on, by using Node.js. And then all of this comes together. So if you do have machine learning engineers who are using Python or only know how to use Python, then you can actually play nice with Node.js as well. So you can actually take a saved Keras model from Python and you can load it via a layers API, or you can take a saved model from TensorFlow lower level and load it via our core or ops API. If you have a Python saved model that you want to run on the client side, so if you're not running on the server side environment, if you want to run in the client in the web browser, we have a command line tool called the TFJS converter that can take a saved model and convert it to the JSON format that we need to run in the web browser. So that is available to do that too. So there's a nice set of tooling here, and depending on your needs and requirements, you might prefer to run in one environment over the other, but there's quite nice environment set up here. Any questions on this slide before I move on to the next slide? Okay, cool. So let's talk about performance then. Here is the performance benchmarks for Node.js and Python for our mobile net model. Running on the graphics card, you can see that in Python, you get a score of 7.98 milliseconds. Running in Node.js, you get a score of 8.81 milliseconds. And this is for inference only. This does not include the pre or post processing. And this is basically within margin of error. If the web server was kind of doing something at a certain time, a millisecond here and there is negligible, basically. So this is basically the same inference times for Node.js or Python. But what gets really interesting is if you consider the pre and post processing, and for those of you who are new to machine learning, in order to use a machine learning model, you need to take the input data, that might be imagery or whatever it might be, and you need to convert it into a form that the machine learning model can understand and digest. Because machine learning models can only run with numerical data, essentially. So you need to convert that image to just numbers and then put that into your system. You often have to do some manipulation, resizing, so on and so forth. Now, if you have a lot of pre and post processing, we've seen that you actually get a significant performance boost in Node.js because of the just-in-time compiler that JavaScript has. And what happens in JavaScript is that the compilation is optimized at runtime, which is unique to JavaScript. And if you're doing a lot of pre and post processing, we've seen that people like Hugging Face, who are very famous in the natural language processing world, they converted their DistilBERT implementation to run in Node.js instead of Python, and they saw a 2x performance increase in speed in execution, basically for free. So this is where it gets very interesting. So they actually took their TensorFlow Python saved model. So they did the machine learning in Python to make the model, but they took that saved model and then did the pre and post processing in Node.js and just loaded that directly via Node, and they got a 2x performance increase. So something to consider if any of you who are looking for these hybrid approaches or just going with Node.js completely. There's some benefits of doing that. So let's talk about some of the superpowers. If you're focusing on the client side, and just a reminder, the client side is the web browser, basically. If you're running in the web browser, then you get the following benefits, which are hard or impossible to achieve on server side. The first one is privacy, which I know is very important in Europe as well, with all the GDPR rules going on over there. And because we're running in the web browser, none of the data that's coming from the sensors is ever sent to a third-party server. So if you've got images of people, sound recordings, analysis of text, none of that will have to be sent to a server for processing. It can happen in the browser on the client's machine. And that's really powerful. You get that for free, essentially, by using TensorFlow.js in the browser. Second point, lower latency. Because you're not having to talk to a server, there's no 100-millisecond round trip time to the server and back again. That could be thousands of miles away from the mobile device or something like this. When you're running on the web browser, you're actually talking to the sensors directly on the device, so the latency is much reduced. Third point, lower cost. If you have a reasonably well-used system, maybe a few thousand users or more per month, you can save this tens of thousands of dollars in server costs because you're not having to run expensive graphics cards and processors 24/7 on the server by offloading all of that to the client side. Fourth point, interactivity. As you've seen from some of the demos I've shown today, JavaScript has a really rich environment for the presentation and display of content and information. This has basically been around since we started, so our libraries for this are very, very mature. For graphing, charting, and 3D graphics, mixed reality, all this stuff you can whip up in hours or days rather than weeks or months. So for that point, it's a good, interesting thing to explore. And then the fifth point, reach and scale. Anyone can click a link in a web browser and get the machine learning to work for free. But as an end user, there's no requirement for me to understand machine learning to be able to use the machine learning. The same is not true if you're doing this in Python or some other language on the back end, because in order to use that code you found, you have to install Linux, you have to install TensorFlow, you have to install the drivers or the CUDA drivers, you have to then find the GitHub repository you want to clone, you have to understand the instructions of that GitHub repository to know how to use that code. And then if all of those things align, you might have a chance of using that machine learning material. So much higher barrier to entry if you're using things on the server side. And of course, as I mentioned before, the GPU support, because we can leverage WebGL, means we can actually run on more devices as well. We're not limited to just NVIDIA-based devices. We can run on MacBooks and other things as well, and you get that for free. Flipping the story to the server side, if we're talking about the Node.js experience, then of course you can run TensorFlow saved models without conversion. So if you do prefer to do your machine learning in Python, that's completely fine. And you can still integrate better with a web team using this method, because most people are probably using JavaScript for the web stack, and then you might have your machine learning team using Python for the ML stack. But with the saved model interpretation for with no conversion, you can just have those two teams work in a much nicer way together. Second point, you can run much larger models than you can do on client side. I believe right now in the web browser, at least for Chrome, you've got a maximum memory limit per tab of 512 megabytes, because people have a lot of tabs open these days and they've got to have an upper limit on those tabs, otherwise things are going to crash. So basically, if you want to run very large models or very complex models, then the only way to do that is in server side. And for that, you can use Node.js to do that, or Python, or whatever is your preference. Third point, it allows you to code in one language. If you're already using JavaScript, and currently, as of 2020, 67% of developers, professional developers, use JavaScript in production already. That gives you, as a startup, a huge benefit, because you can just have a smaller set of people working in one language for consistency, and you don't need to hire as many people in different languages too. That can be a big benefit for startups, especially when you need to be more lean and nimble in such times. And of course, as you scale, you can, of course, move into other things, and maybe you want to use Python for certain things, that's fine too. But as you're starting out, this could be very powerful and save you a lot of money and time. Fourth point, the NPM ecosystem, which is Node's package manager, is very robust now. It's battle hardened, it's been tested, and it's just like the JavaScript in general, has a lot of libraries that you can leverage now to do many of the things you need to do. And then the fifth point, of course, we spoke about it before, but the C bindings are the same as Python, so you get the same performance, but you get the just-in-time compiler boost, which you don't get in any other language, as far as I'm aware, to get that extra performance boost for the pre and post processing. So I'm going to end with resources here. Basically, if there's one slide you want to screenshot today, you should check this one out. These are all the links you need to get started with TensorFlow.js. We've got our website that has tons of useful information. We've got our models. So I just went over 2 or 3 models today. We've got like many, many more of really cool models that are easy to use to get started with. If you check out this link, you can find out more about them, and they're just as easy to use as you saw in the examples today. We are a completely open source project, and we encourage people to contribute if they've got ideas. Our code is completely open source on GitHub, so you can check our GitHub link there if you want to see the code, how TensorFlow.js works, or maybe you want to submit your own suggestions. That's completely fine. We have a Google group as well for more advanced technical questions. Our team monitors that from time to time. So if you have something that's really niche, that could be a good area to ask those kinds of questions. And of course, we're also available on Stack Overflow as well. And then, as I mentioned, I've made some boilerplate code for common use cases, like how to access the webcam, how to access various sensors, and use it with our pre-made models. And you can find that code on CodePen and Glitch. And you can just copy those examples very easily, and you can be up and running in minutes. And then my recommended reading is this book called Deep Learning with JavaScript. That's been written by people on my team, some of the founding engineers of TensorFlow.js, and even engineers on the TensorFlow team at Google, created this lovely book. And if you're new to machine learning, it will take you from the very basics of linear regressions and all these simple things, all the way to more advanced features like GANs and generative networks and this kind of stuff. So it really will take you from zero to hero in machine learning. The only prerequisite is to have some understanding of JavaScript. If you're new to JavaScript, I can give other resources to learn that if you're interested. There's many free courses online to learn JavaScript. But this book is really robust, and there's also some various training materials by our community, and there's someone else on my team called Lawrence Moroney who's made some really cool Coursera courses for both Python and TensorFlow.js in more like video form as well. So I can give you links to both later too. So my only question left here is that come join our community. We're growing all the time. As I mentioned, TensorFlow.js actually started much later than the core TensorFlow, so we're much newer than core TensorFlow. So we're only like 2 or 3 years old right now, but our community is growing very fast. And you can see here just a few other examples of people making amazing things in these GIFs. And if you do make anything, if you use the hashtag #MadeWithTFJS, we can find that and we can kind of find you and talk to you and ask how things are going, and maybe even share your work at our future show and tell events that we do every couple of months, which give people more exposure of what people are making, which is great. And just to end with one final piece of inspiration here, I just want to share this guy's work from Japan, Tokyo. He's actually a dancer by day, but he's managed to take TensorFlow.js and use it to make this really cool hip hop video. And I guess my point here is that machine learning can now really be for everyone, not just for researchers and scientists and engineers, but I think with TensorFlow.js, it opens up to so many more people. And I'm really excited to see how we can make that happen for everyone from any different industry, musicians, artists, creatives, whatever it might be. I'm really excited to see how this evolves over the next few years. And I'm hoping that we can be part of that story to help people with that. So with that, if you want to stay in touch with me, I'm available on Twitter and LinkedIn. So I'm happy to answer questions there if you don't want to talk today for some reason, but I'm also happy to take questions now if you've got any questions that came up in your mind. So thank you very much for listening, and over to you for any wrap up and questions. Thank you.